And now we present our results from the experiment. So first, in figure 1, we can see how the orange line that represents the surface tension didn't change. The reason why is because even though we increased the volume of soap on intervals of 2 milliliters until we reached 10 milliliters, the surface tension broke on all the trials. And now we pass to figure 2. Here we can observe the same pattern but on intervals of just 1 milliliter until 5 milliliters. And as in figure 1, while the soap was increasing, the surface tension broke. In both figures we broke the surface tension, and that's why we don't have a standard deviation in them. And also our average is that surface tension broke. Despite there were different amounts of soap, both figures showed that our surface tension broke. And that's all.
Our hypothesis was that if soap was added to water, then its surface tension would break because soap separates the molecules of water between each other. And after doing our experiment, we support our hypothesis. As we can see in figure 1, all the possible volumes of soap broke the water surface tension. And in figure 2, the same thing happened even though we reduced the volume of soap. This could have been due to the small recipients that we used in our experimentation. Maybe the volume of water doesn't affect its resistance to break its surface tension, but the distance and the displacement of the water might be of importance. To be clear, following this logic, we could have a recipient of 10 meters long with a very small opening, and its surface tension would break. Nevertheless, however, if we have a container that is 10 meters long, then a single drop of soap won't affect it. Although that would be another hypothesis, it is food for thought. In our previous research, we became aware that soap reduces water's tension about a third of its total surface tension. As our first source contributed, soap does break the surface tension of water because the hydrophobic ends of the soap, the part that is made of grease, that is, tries to find its way out of the liquid by pushing the hydrophobic parts outwards. Hence the name. Hydro means water, while phobia means fear, so they are said to be afraid of water. That is what causes tension to break. Later on, our second source confirmed that water does have surface tension, and it provides an explanation. Atoms share the cohesive force placed on them with the neighbor atoms. The atoms on top share this force with the nearest atoms that are also on the surface. This allows them to send very light objects placed on top of the water. Finally, according to the third source, the surface tension of water can be broken by changes in temperature, oxidation, present impurities, and, certainly, chemicals that modify the bonding of characteristics of the fluid. That is our case, seeing as soap affected the link between the atoms. This is the reason why when you wash your hands or any object with soap, the water atoms links are modified, making the soap easier to slide.
Limitations and errors. The limitations that we encountered during this experiment were how much water we could use in a container, so we were not able to test on bigger amounts of water. One of the errors encountered in early tests was that it was hard to determine if the force of the drop was that caused the surface to break. This was an issue until we drastically reduced the height where we dropped soap. Investigating surface tension is also important, because in a world without surface tension, even the smallest particles would sink into the water rather than floating on it. Surface tension is also important on the cellular level, where it holds the cell together. Overall, this is something that affects greatly in our daily lives, so people should take more interest on it and possibly investigate more on how to apply this phenomenon to our advantage. Conclusion. Having measured and compared all of our results, we can conclude that our hypothesis was correct in that soap does break the surface tension, and also that no matter how much soap was added to the water, it would always break the tension.